Hey math enthusiast, I'm here to go over some more practice problems from section 9.5 dealing with composition of transformations. For number 4 here, we're dealing with segment FG. So first let's graph that. So what I want to do for this problem is perform both of these transformations, the rotation and the reflection, first in order. And I want to see where I'm going to end up. So I'm going to do that first one in all red. Now the first thing I want to note is that my rule for a 90-degree rotation about the origin, it's going to change my point from xy to negative y x. So first thing I want to do is apply that rule to my original points, f and g. So I'm going to get f prime, which is going to end up at positive 4, and g prime, which is going to end up at positive 2, positive 1. Now, I don't want to graph that because after that, I want to reflect it over the y-axis. Well, I want to jot down what's my rule to reflect over the y-axis. Well, the x-coordinate is going to change signs. So now I'm going to come up with my final points, f double prime and g double prime. So f double prime is going to end up at negative 4, positive 4. And g double prime is going to end up at negative 2, positive 1. Now I can graph these 2 points. So when I perform these transformations in order, that's where I'm going to end up, where that red segment is located. So now I want to go back and I want to do the same thing but in the reverse order. So I'm still going to be focused on my original points f and g, but now I'm going to start with the reflection. So this is going to give me f prime, so I'm using my rule that I wrote down earlier, which is going to lead me to negative 4, negative 4. And g prime, which is going to lead me to negative 1, negative 2. Now I'm going to take these single prime points in blue and I'm going to apply the rotation rule. So that's going to give me f double prime. So for this point, I'm applying this rule. So they're going to switch and then that y coordinate is going to become positive. So I'm going to be at 4, negative 4, and g double prime is going to end up at 2, negative 1. So in this case, f double prime ends up in the same exact location. G double prime is close, but it's a little off. But this clearly shows that the order makes a difference. When I did it in the order that they gave me, rotation, reflection first, I ended up in the second quadrant. When I did it in reverse order, I barely moved, and my segment still remained in the fourth quadrant after those 2 transformations. So for number 5 now, I want to come up with a single rule that will perform both or all 3 or all 4, however many transformations in one step. So for number 5, they want me to rotate 270 degrees about the origin and reflect over the x-axis. So first, before I get started on this problem, let's just come up with a random point and we'll perform this transformation too. So if I have a at 3, negative 5, first thing they want me to do is 270. I know it's going to be counterclockwise about the origin. My rule for rotating 270 about the origin, my point is going to turn into y, negative x. So now let's apply that to point A. So I'm going to end up with a prime, which is going to be at negative 5, negative 3. Now what I want to do with a prime, I want to reflect over the x-axis. So we have a separate rule for this. When I reflect over the x-axis, what's going to change is my y coordinate. It's just going to change signs. So now it's going to lead me to a double prime. So I'm going to end up at negative 5, positive 3. So what I want to try to figure out for this problem is how can I go from A directly to a double prime? All right, so think about how my points changed. And I want to come up with one rule to do that. Now, to come up with this rule, instead of using a specific point, I'm going to use an arbitrary point. So any point on the graph. So my rule for 270, we just wrote it down earlier, is going to be y negative x. So that's the first thing I'm going to apply to my point. So I'm doing the 270 rotation about the origin. And that's going to change my point to y negative x. So you have to remember that even though it's switched and that first coordinate says y, this is still the x in the front. This is still the y in the back. Now what they want me to do is reflect over that x-axis. So reflection over the x-axis. We jotted down that rule earlier. I know my point is going to change to x negative y. So the rule tells me that that second coordinate is going to change signs. So this right here is going to change signs. So what's going to happen is my final point is going to be y x. This is the rule that I want. What this rule will do is for any point, it will rotate it 270 degrees about the origin and reflect it over the x-axis, all in one step. So for part B, now I have two different types of transformations. So I want to start off with my arbitrary point, so any point on the graph, x, y. What they want me to do is first reflect over the line y equals negative x. So let's recall what that rule is. My point would change to negative y negative x if I reflect over that line. So the first part's easy. So I'm going to perform that reflection, and it's over the line y equals negative x. So my point is going to change into negative y negative x. After that is a translation using this vector. So remember, this component form tells me that my x coordinates, I'm going to add 2 to, and my y coordinates, I'm going to add 5 to. So, translation, and then my vector is going to be 2, 5. All right, I'm actually going to write this one down below just so I have a little bit more space. So now remember that this is your x coordinate up front. So it's going to be negative y plus 2. And it's going to be your y coordinate here, which is negative x, and then apply the translation, plus 5. So in this case, if I take any point that I want on the graph, I don't know, let's say A, which was at 3, negative 5, and I want to reflect it over this line and translate it using that vector, all I have to do is plug these points into my final rule down here. So your negative 5, this is your y. That would be plugged in here. And your x, which is 3, that would be plugged in for the second part of the rule. So in this case, the negatives cancel out. I add 2, which gives me 7. And then we have negative 3 plus 5, which gives us 2. So there's my final coordinate, A prime, after the reflection and the translation.